basically architects. All right, some of you must work for startups because some of you are raising your hand for everything. Okay, how many are managers that don't really code a whole lot? Okay, some. Okay, and this is always a tough thing, right, about an audience is how do you, target the audience properly. So I'll have some high-level stuff, and if we need to dig down, we can dig down. I'll be happy to do that. So, okay. How many, out of the hundreds of you in the audience, because this is being recorded, nobody can really see how many are in the audience, right? So, how many in your audience have actually heard of OpenShift application runtimes? A couple of you, okay. So, just for the record, there's probably only about 30 or 40 people in the room, so. Okay, so talk about OpenShift application runtimes. And there's a little bit of context around some operations, some context. Really, at the end of the day, it's making your developers more productive, right? Running on OpenShift. But okay, a couple more questions to scope things out. How many of you kind of know what monoliths are in the context of like application development? A monolith. Microservices. Ever hear microservices? Okay. So do a little bit of ground setting. Basically, the way we've been traditionally writing applications, if you think about whether it's .NET over the last decade or 2 decades, traditional Java EE, traditional Spring framework, the way developers tended to write applications, kind of encouraged by the runtimes and the way some of these platforms are designed, is to create monoliths. And that is, I basically designed this application to include an awful lot of functionality, right? So if you can think of a retail store, it's got the shopping cart, it's got the customer information, it's got the billing system and all this kind of stuff. Pieces of that are all kind of in one big application, right? And that's kind of the definition of a monolith. And that's pretty much how I think a majority of people today are deploying their applications, is to traditional Java EE application servers or .NET or whatever, right? Kind of these rather large, feature-rich platforms. And what these platforms tended to do is they mixed the idea of application APIs, but also operations, right? So with these platforms, they provide the functionality, the administration functionality to manage the life cycle of an application. I can deploy an application, enable it, disable it, undeploy it. These platforms also do things like let me deploy new instances of the platform, instances of an application server. So I can, if I have a server farm, I can go deploy a new instance of an application server, start it up, and then, so that way I can deploy applications to it. So there's all of this kind of management infrastructure built in, as well as kind of a programming API, right? So that's how we, have been developing traditional Java EE, traditional Spring framework stuff for quite a while. And did any of you attend Rich Sharple's talk yesterday, kind of about middleware application platforms? It was one of the first presentations. Okay, I definitely recommend, and I have a slide that'll show sessions, but if you go and watch replays, definitely kind of take a look at his session, because this provides kind of an additional view on top of that, right? But the idea is that Java EE has been, in a sense, maturing, right? The releases aren't as frequent as they used to be. And traditional Java EE application servers are kind of designed for this approach, where you have, the administration functionality as well as the programming APIs that developers use all built together. And it's slowing down, and things like microservices are picking up speed, right? So, the question is, how do we go from monoliths to the microservices architecture running in the cloud? And the nice thing about JBoss EAP is, while the Java EE market is basically staying relatively constant in terms of overall market size, or slightly growing at maybe 3%, JBoss EAP is really growing at about 33%, because what's happening is a lot of customers are consolidating their Java EE runtimes onto JBoss EAP, right? It's very flexible, very mature, and much more cost-effective than, for example, WebSphere or traditional WebLogic. So we have tools. If you were at the keynote, you even saw James Faulkner talk about how you can take a Java EE application running on one of those application servers, run it through a tool called Windup that basically does a little bit of tweaking of the configuration and maybe even some application changes, make some recommendations so that you can easily then deploy it on top of JBoss EAP, right? So this is still kind of the traditional monolithic way of development. We're just taking existing monolithic applications that are rather large and feature-rich and just re-hosting them on a different application server. So now what we can do, and you saw this also in James' talk, about how we can take these applications running on JBoss EAP and just lift and shift, right? You lift them out of your traditional deployments and you deploy them onto OpenShift in a containerized environment. And what's interesting about this, and I apologize, some of the lines didn't really show up around the outside, but it doesn't really matter. This slide in detail is really just meant to show that whereas in the past, application servers provided all this administrative functionality, what's going on now is the cloud is replacing that functionality. Right now, the cloud is the tool that you use to deploy applications. It's the tool, or they provide the tools, for you to deploy your applications, right? So we're shifting the administrative responsibility from a product, like a Java EE application server, to a cloud, right? And the nice thing about that is that same model works not just for Java EE apps, but for kind of any application runtime, right? So you get leverage across many different kinds of application runtimes. Okay. Now, when we think about monolithic applications, Martin Fowler is kind of one of the big thinkers around the idea of moving to microservices. And I'll define that here in a second. But Martin Fowler basically says, before you move to microservices, make sure that you've really defined your monoliths well. Because in a microservices architecture, what you're really doing is you're splitting up these large monolithic applications into many smaller pieces. And the idea behind splitting them up into smaller pieces is that I can then divide up my development team along each one of these individual pieces, and they can all move at their own pace. And when I make a change, whether it's a bug fix or a major new feature, I can deploy that at my own pace, whereas with a monolith, there's this case where if I introduce major new features, all the other people working on all the other functionality get really nervous, right? Is it going to break my part of the application? With microservices, everybody owns their own piece, and all these different pieces of the application talk to each other over the network. But the important thing is that you really understand your domain model. And the idea about the domain model is, how do I map my business into software, right? And if I don't do that properly, in a monolith, the implications are, I may have issues around maintenance, and I can refactor my code and make it more streamlined. But if I do that in a microservices architecture where I split up these pieces, these applications into many different pieces that are owned by different teams, I've got a network in between, right? And so if I don't model my application right, all of a sudden I've got this problem of performance is going to tank, because if I have all these services cross-talking on the network when they might not necessarily need to, you've got potentially a big performance problem. And there's other architectural problems as well. So the idea is, make sure you have your monolith right before entering into the world of microservices. And again, having the monolith right means make sure that you've modeled your business correctly inside of the monolith before you break it up into microservices. That's the idea. So there's this concept of the majestic monolith. Monoliths aren't necessarily a bad thing. What people tend to think, on the downside of monoliths potentially is, if I have one big application it's really easy for me to have all of these different pieces of the application become intertwined, right? It becomes really hard to maintain over time because things like schedules tend to get in the way, right? I need this feature by next week, and if you don't have the feature by next week, it could impact the business. So what people tend to do is take shortcuts. And when you take shortcuts, you end up with this, what's called a big ball of mud. You use this monolithic application that was neatly architected, over time tends to become this big, spaghetti code is what they call it. So the majestic monolith basically says, if we have a well-architected monolith and we've split up our teams to own pieces of that monolith, the monolith isn't necessarily a bad thing. It's easy to debug, it's easy to develop to, there's lots of benefits to a monolith. So what KeyBank did, and I have a link there to a blog post that really kind of digs into what KeyBank did, is they basically, instead of rewriting their entire application to break it from this big monolith into smaller microservices, what they did is they just took pieces of the application and kind of microservice enabled it, where it made sense. Even a monolith tends to talk to external systems, right? You may have to talk to an ERP system from your application, for example. And there's microservice patterns for how do you deal with failure if your connection to that ERP system goes down, right? There's microservice patterns that even apply to monoliths. And so they kind of refactored some of their code to leverage some of those concepts. They also adopted OpenShift and Kubernetes as a container platform. That gave them a lot of operational efficiency, right? Because now I have this container platform, and I could rapidly provision either new applications or rapidly upgrade this application, because they went from this this operations perspective where they had like 70, I forget what the number is, like 70 manual steps you'd have to take to actually push their product into production. And between having an automated environment with containers and the concept of development pipelines with continuous integration and continuous delivery, they were able to basically reduce their release cycle from 3 months to a week, right? And we have to ask ourselves, is a week fast enough, right? Do we really have to go to a full-blown microservices architecture to achieve, increased speed of delivering features into production? Or is a week fast enough for most enterprises? And so that's where we think about, the majestic monolith. And they also did some other things, by the way, in terms of how the operations team and the development team kind of work together. They kind of changed that structure a bit, where the ops team, who went from owning an app server and all these products, to simply owning the cloud. And then the developers owned basically anything above the core cloud, anything basically above OpenShift, you can think of it that way. And that also means, with great freedom, you can choose what you want to do, but great responsibility. It's your job to keep it running, right? And to patch it and all that stuff. So it definitely shifts responsibility around. And they also got to, as part of going to 1 week, they also basically got rolling deployments. They could just easily upgrade their app with zero downtime, right? Leveraging OpenShift. So now let's think a little bit about adopting microservices. And how do we make our developers more productive? So when we move to the cloud, we really get a lot of operational efficiency. Now the question is, how do I make my developers more productive? So there's various ways of looking at parsing that, right? When I move from a monolith to a microservice, the idea is I'm changing the way I develop applications. I'm going from, again, this big bang ball of features to decomposing it in these very small siloed applications that all talk to each other. And that allows each team, again, to define their own upgrade path and release cadence, right? So one team isn't slowed down by another team. You get a lot of speed out of that. But part of the problem is, think about it from a developer's perspective. I've got a cloud that's new, probably in my environment. I'm moving from a monolithic application architecture to a microservices architecture. I might be adopting new language runtimes, right? Whether it's Node or Vert.x or Spring Boot or whatever. there's a lot of changes that developers are kind of dealing with all simultaneously. And so what we want to do is make that as painless as possible. So what are the paths that a developer can take to become more productive? Well, if I have a traditional Java EE environment, I'm using the Java EE standards, I'm running on top of JBoss EAP, where I mentioned, if it's WebSphere or WebLogic and you kind of rehost it on EAP, what's the path for me to get to microservices? That's where we have something called Wildfly Swarm. Wildfly Swarm basically takes the pieces of JBoss EAP that your application needs. Maybe it only needs to talk REST over a network into a database, and that's it. And then you sprinkle in some business logic, right, that's relevant to the problem you're trying to solve. Wildfly Swarm will take those basically pieces of the application server, package it along with your application into a single deployable artifact, a jar file. Then I can just run that from the command line. So what we've done is we've taken basically Java EE and turned it from a platform where you write your application and deploy it to the application server to actually packaging the application server with your app and then deploying that on top of the cloud, right? So we've also gone the extra step. We've gone the extra step where we're now working with adding microservices technologies, if you want to call it that, to Wildfly Swarm. So in the microservices world, there's very common development patterns. How does one service locate another service running in the cloud? It's no longer at a single IP address necessarily, right? Because you have these services coming and going all the time. You scale them up, you scale them down. How do they find each other? So another one is, how do I deal with failure? If I'm breaking this application up into many pieces, the odds of one piece failing go up, right? So whether it's a problem of the application, the platform, the hardware, whatever, that application may go down. So how do you deal with failure? So there's something called circuit breakers and bulkheads, ways to deal with failures in your environment from a developer's perspective. So what we're doing is we're basically solving some of those problems from a microservices sense in Wildfly Swarm. So we're extending traditional Java EE to adopt microservices patterns as well. And you can combine the pieces of Java EE you need with the right microservices technologies that you need all in your application together. And it's all very seamless. And the Java EE pieces are built from upstream, an open source version, Wildfly, but in terms of product, the JBoss Enterprise application platform. Now what you see there on the right here is something called Eclipse MicroProfile. So one of the nice things about Java EE is it's a standard. The idea is that you're not locked into one vendor, you have choice. And the fact that we're actually doing really well at rehosting competitive application server, apps written for competitive application servers on JBoss EAP shows that a lot of our customers are executing that choice, right? They're making that choice to rehost their app. And that's only enabled by something like a standard, right? So what we're doing is, well, in the microservices world, Java EE wasn't quite moving fast enough to add the microservices technologies to the standard, right? It's in the roadmap. We'll see if it gets there. But we didn't want to wait. So all of these Java EE vendors were going off trying to solve the microservices problem. And that began to kind of split the community. So we had Wildfly developers that were developing microservices. We were trying to introduce easier ways to write microservices. Same thing with all the other app server vendors. IBM, well, almost all the other app server vendors. IBM, Pyara, Tommy, and so on. So what we decided is let's not split this Java EE community that's worked well together to go off and do microservices. Let's all continue to work together, but let's do it in an open source manner in an open community. And we could have done it theoretically through the JCP, the Java Community Process, which is where the Java EE standard is defined. But the problem is we needed to move faster than you want to move in a standards organization, right? Standards is all about stability, backwards compatibility, And we're trying to still innovate. We're still in the innovation phase, which is why we went off kind of as a community and created MicroProfile. And so what we're doing is we're all collaborating and we're iterating on these technologies. We have calls every week. Any one of you can join the calls and listen in. Any one of you can join the MicroProfile Google group and begin participating. Hey, how do I bring microservices into Java EE? Lots of different threads about all these microservices things that you're hearing about. We even have now kind of this subgroup that's off kind of doing the marketing around this, right? Whether it's vendors or individuals. So at the end, what we want to pop out is more standards, right? So if standards are important to you, and have been with Java EE, this is how we get to standards in a microservices sense, right? For the traditional Java EE community. So we want to provide that safety for our customers moving forward. So the MicroProfile is kind of a way to accelerate that, right? So MicroProfile is an open source community, kind of. It's not necessarily a standards community, but we are working on specifications, multiple implementations of these specifications, and eventually, again, we'll look towards standardizing. So lots of vendors are involved. Pretty much all the major vendors except Oracle right now, and they've been invited, and we hope they join. So another path that you can take is, we've heard about reactive development. We like the idea of reactive development. And reactive development basically means I'm developing an application so that I'm always reacting to events. Somebody makes a request, I react to that request, execute some business logic, and return a response. And that's built throughout the entire system. Same thing with talking to a back-end ERP system or talking to a database. It's basically a way of doing development that is it's considered very fast, single-threaded. For you developers, it's typically, you don't deal with multiple threads and concurrency issues. It's basically an environment where everything is kind of single-threaded, and that's designed into the environment. It's all about concurrency and low latency. And Vert.x is really good at that. And Vert.x has, think of it as Node.js for the JVM, in a way. But it has its own libraries, and there's language bindings to Java, JavaScript, JRuby. You can see all of these things. And when we get to actually productizing, we're going to start with just the Java piece and talk to folks like you and figure out, do we need to do JavaScript and so on. But the idea is, again, if I'm a Java shop and I want to do reactive programming, this is a really good way of doing that. That's a path to get to microservices. Another path that some of you may be taking is, if you're a traditional Spring shop, Spring framework, running on EAP or any other application server, then you might decide that Spring Boot is the way that you're going to go to do microservices. So what Spring Boot does is provide a very opinionated way, meaning they define this well-defined path. If you program along this path we've defined for you, you'll be really productive. Right? And what they take this opinionated approach using the historical Spring framework along with some additional glue code to make it very productive. And we've already certified Spring Boot with some of our technologies. So we have a Java image that runs on top of OpenShift, for example, that'll run any Java application. We've certified Spring Boot running on top of our Java image. And we also support, for example, our embedded Tomcat container within Spring Boot. Because the way Spring Boot works is it needs some Java EE technologies just to get off the ground, right? To basically even boot up. And so we support some of those Java technologies that are bundled in Spring Boot. And what you're going to see is, today it's just the servlet container, Tomcat, but over time you're going to see more and more pieces of our Java EE technologies being supported within Spring Boot. So things like Hibernate, CXF for doing RESTful development with Spring Boot, and so on. So we're doing a lot of work around certifying Spring Boot running on OpenShift. Okay. Now, to kind of introduce you to something that we announced, we had a press release go out yesterday on this, the Red Hat OpenShift application runtimes. So what we've kind of talked about very generically is here's a path for you to go from where you are today, maybe it's Java EE, maybe it's Spring, to potentially other language runtimes that are doing, microservices style development. And let's do a quick time check here. Okay, so Red Hat OpenShift application runtimes basically either supports these language runtimes in the case of JBoss EAP, Wildfly Swarm, Vert.x. We're actually bringing those to market through the OpenShift application runtimes. And around Spring Boot, I mentioned, we don't actually support the Spring Boot bits themselves, but we've certified Spring Boot, and you'll see us certifying more and more of the Spring Boot ecosystem. But we do support pieces of Spring Boot that rely on technologies that we already have, right? So you can run your Spring Boot applications on OpenShift, and we want to make it basically easy drop-in for Spring Boot applications running on OpenShift with basically no work at all, right? You just change your configuration file, and for your developers, the POM file, change your dependencies, and things should just run. Now, what does this really mean? So OpenShift itself, Kubernetes, right? OpenShift is layered on top of Kubernetes. Kubernetes and OpenShift provide an awful lot of features that are relevant to development, to developers. And things like I mentioned before, how do I do service discovery? Well, that's a capability built into OpenShift. How do I do load balancing? That's already taken care of by OpenShift. How do I externalize my configuration, right? So if I want to keep my configuration of my application separate from the application itself, right? So I externalize it somewhere. I need to store that configuration somewhere. It's built into OpenShift and in Kubernetes, right, through something called config map. So what we're doing is we're actually integrating these language runtimes with Kubernetes. We're doing that work. We're either modifying our existing implementation, adding new frameworks, whatever it takes to kind of make running these runtimes on top of OpenShift and Kubernetes as natural as possible, okay? And taking that kind of the next level, we're also doing that same thing with our other middleware. So if you want to run a cache or a distributed data grid inside of OpenShift, we want to make it as simple as possible for your application to discover where that cache is and be able to put data in and out of that cache, make it as simple as possible, pretty seamless, right? We're already doing that with Red Hat SSO. So you can secure your RESTful endpoints, for example, with Red Hat SSO and provide kind of a single sign-on functionality. And that's something that we've already done the work on. And we're going to continue basically integrating all of these language runtimes into the Red Hat middleware, all running on top of OpenShift, right? So we have kind of our backlog. Our list of things to do include the logging system of OpenShift, API management with 3Scale, ActiveMQ for messaging, right? So we're just getting started, right, with the SSO. So again, we're doing all the heavy work with running these language runtimes and integrating them with OpenShift and our middleware so that you guys don't have to do that. And we're also making sure that the experience is very productive, whether you're running in a local IDE developing this work, if you're developing to OpenShift.io, if you remember we announced OpenShift IO, think of it as an online developer experience. We want to make sure all these language runtimes fit naturally into that, along with the whole deployment and development model. And we also have this idea to get you started even more quickly called launch.openshift.io. And I'll explain that here in a little bit. And then that's kind of on the right-hand side. On the left-hand side, we want to also provide some additional management and I'll just call it management and monitoring capabilities. So if you have these services running in this large cluster with hundreds of physical servers, and you don't know where your actual software instances are running of your application, how do you trace the paths of all these requests as they go from service to service to service? How do you know where the bottleneck is, right? So this is functionality that we're building right now. Application Performance Management, APM, basically will do that kind of distributed tracing for you and help you figure out where the performance bottlenecks are, along with leveraging Hawkular metrics, which is basically a way of acquiring metrics of all your services and storing them into a database so you can go back and kind of do, on a service-by-service basis, go back and do kind of performance analysis. And then, as I mentioned, we're also going to be doing some certification work. So I mentioned Spring Boot, but that also includes some of the other open source technologies like Netflix OSS, Hystrix, and some of you developers may know this, for basically providing circuit breaker functionality, but also the Hystrix dashboard so that you can actually take all, understand where the failures are, track the failures all through what's a Hystrix dashboard. Same thing with Ribbon and client-side load balancing for example, Spring Boot. And if there's other open source frameworks that you think are important to your business, then we'll look at certifying those as well, right? I mean, that's kind of the value that Red Hat offers, right? Is you can work with us, we can work with you, and help you. Well, you can help us, yeah. We can help you basically pick the right set of, where should we certify, where should we build, right? How do we improve this over time? There's a lot of things we can do here. All right. So what's interesting is if you look at OpenShift from a much broader sense, it's really good at running existing applications. I don't have to, basically, you don't have to assume that, well, if I'm running on top of OpenShift, then I have to be doing new microservices development, right? And that's what it's good for. It's like, no, you can actually take your existing applications like we talked about and run it on top of OpenShift. And that actually might be a good idea for a lot of your applications. If you have applications that aren't, that don't have to be updated very often, if they don't maybe perform a critical business function, and they work just fine, then keep them as monoliths. Just lift and shift and run them on OpenShift. The other thing is if you look at the big picture with OpenShift itself and the application runtimes, we support multiple application architectures. So we support monoliths, fast-moving monoliths, like the KeyBank example, where they've taken a monolith and moved it to basically a weekly release cadence. We support microservices, and we're even working on serverless, right? So how do we do serverless on top of OpenShift as well? So we can support multiple application architectures. Obviously, we support multiple programming languages or programming runtimes. So I mentioned Spring Boot, Vert.x, Wildfly Swarm, JBoss EAP. We're going to be doing Node at some point. That's in our plans, hopefully later this year. Again, all integrated with OpenShift services, whether it's the middleware running on OpenShift or OpenShift itself, right? So we're providing you, very rarely do I run into a customer that's running just one thing. They're not running just Spring Boot, they're not running just Java EE, they're not running just .NET or whatever. They have multiple runtimes in their environment. And the idea is we want to make it as painless as possible for you to take those applications and that experience that you have, the developer experience, the operational experience, as much as possible, and bring that over to OpenShift. So we launched something, pun intended, yesterday called launch.openshift.io. And if you go to launch.openshift.io and you're a developer, which is what this is geared toward, you can sign up for early access to basically running these language runtimes, running examples that we have. We call them missions, right? They're use cases, predefined use cases like securing a RESTful endpoint or doing a health check. So OpenShift can detect when an application is unhealthy and restart it. Well, on the other side, an application wants to provide to OpenShift perhaps its view of whether or not it's healthy, right? And so we basically provide that link with with the integration work that we've done that I've mentioned before, and there's examples about how to do health check on this, within the application, expose the health of the application to the runtime. There's examples for that, right, and so on. And right now it's early access. You can get on the early access list if you go there, and then you'll have a completely online development experience, right? What it'll do is it'll take take one of these use cases. It'll actually fork it to your GitHub repository. Again, this is a developer thing. And as a developer, you can still download it locally and play with it and run it locally. But it'll also, after it forks it, then take it and deploy it inside of a continuous delivery pipeline inside of OpenShift, right? All with just a couple of clicks, which is really nice. And because it's not quite available yet, we also have the ability for you to do this yourself locally on your desktop using something called MiniShift. MiniShift is basically OpenShift running on your desktop, right? It's really easy to set up and install, and you just basically say MiniShift start, and it just downloads everything it needs to download, and you're up and running with OpenShift. And then what we do is we provide you instructions to basically go off and download this online experience. It's actually pretty easy. All you do is you fill out a form with just a couple of pieces of information, and it'll go download the Docker images to run actually this online experience, but do it on your desktop. So you can take a look at these runtimes running on your desktop in a CI/CD kind of environment, right? All, again, just running in OpenShift on your desktop. So it's a really good way of developers to take a look at how we've integrated these language runtimes into OpenShift. And I should also bring up that OpenShift Online Starter does have a 1 GB limit, which means we can't run all of our examples in OpenShift Online because some of them have databases and stuff like that. So you'll get a subset of what we offer if you take the online experience. If you download it locally, then you basically get all of our examples, right? And when we have OpenShift Online available in a broader sense with paid levels and all of that, then you'll be able to run all of them online as well. It's just that the starter has a 1 gig of RAM limit. So just for the developers in the room, if you want to see everything, consider downloading the full MiniShift experience as well. All right. We are conducting a survey, if you could take a picture of this. If you've already seen this in other sessions, you don't have to take the survey again. It'd probably ruin our data, right, if you did that. But the idea is, we want to find out where, are you still doing Java EE development? If you're doing some Java EE, but you're also moving to other language runtimes, what are you moving to? It's those kind of questions. It basically helps us define our roadmap for what we should be doing based on what you want us to, or what you want to do, right? We want to make sure that we can support you as best as possible. So, for example, do we need to add another language runtime? Stuff like that. This just helps us out with our planning, and data is king with that kind of thing. So there are other sessions for you to hear about application platforms. Unfortunately, a couple of them have already passed. I made a reference to Rich Sharple's presentation, but these are all going to be recorded, right? So you can go watch these. I think they're going to be on YouTube. You can go watch them online, and if you happen to miss the session while you're here. So the ones I want to point out is there is a hands-on lab for how you go from Java EE monolith to a Wildfly Swarm kind of microservices transition. There's a hands-on lab later today on that. If you're interested in Java reactive systems, we have a talk on Vert.x tomorrow. There's also one competing with the session, that competes with the session Ken and I here, we have some of the team in front, are doing on Wildfly Swarm and MicroProfile. It's really developer talk, right? Both of those are developer talks. So we're going to show code, show examples, IDE, stuff like that. Rich Sharples will be doing a function as a service, basically serverless talk tomorrow as well. And then there's also another Vert.x presentation in the afternoon on Thursday. So we've talked about some of these runtimes, and now you can go actually look at them at a deeper level or even get some hands-on with it, right? And there's even, it missed, it was yesterday, there was also one on Spring Boot and Spring Cloud running on OpenShift, right? So there's a session on that as well if you want to kind of see how, how we've done that. Edson Yunaga is doing that one. So again, you can watch it later, the end. But, so let's see, how much time do we have? We have 5 minutes or so. Do we have any questions? Okay, yes? Minishift, good question. Is Minishift available? Minishift is available. If you go click on, if you go to launch.openshift.io and you want to try this out online, or sorry, try this out locally, there's a link where you can go to the instructions, and in that link is instructions on how to install Minishift. Now just be aware that we've done our testing with this on beta 5. Minishift was like released, Minishift 1.0 was released yesterday. I don't know if we've actually done the testing on it yet. So if you want to try it in this context, use beta 5. If you want to try Minishift just very generally, then you could try 1.0. It says that in the instructions. Okay, thanks. So just be especially wary, not wary, but careful about that. So I thought maybe I'd just do one quick thing showing you a little bit of the get started experience. Are there any other questions? Because we have a couple minutes left, yes. So the question is, when it comes to Java EE or Wildfly Swarm, which is kind of Java EE and with microservices, and Spring Boot, are we seeing these as two totally separate things? Are we going to work? Are we going to consider them working together collaboratively, running inside of OpenShift? Good question. So one of the things that we definitely want to do is we're running these use cases, these tests, right? And these tests span features in OpenShift through the language runtime up into our middleware stack, right? So example, Red Hat SSO. So we're trying to do end-to-end use cases, not just testing very discrete pieces running inside of OpenShift. So one of the things that we want to do some testing around is how does a Spring Boot app discover a Wildfly Swarm app, and maybe you deal with the failure use cases like circuit breakers, right? But between these things, to be honest, if it's all just JAX-RS, it shouldn't really be that complicated, right? Because it's all just HTTP. But if you have specific use cases that you think that we should be addressing, definitely let us know. But we definitely aren't seeing these things as very vertical stacks along the language runtimes. As I mentioned, we expect customers to be deploying not just one of these things in their environment. We expect them to do multiple language runtimes. It might be, it's a big organization, different parts of the organization chose different ways of doing it. It might be dealing with acquisitions where you acquire a company that uses a different technology. So yeah, we definitely want to make sure that these things do talk to each other, all running on OpenShift in this way. So let's see how we're doing on time. All right, just one quick thing I'll show you. This is especially for the kind of the developers. This is actually OpenShift running in Minishift on my desktop. And this is about 4 gigs of RAM, and I can deploy lots of these examples, probably, I don't know, at least 3 of these examples, running in OpenShift on my desktop. I'm not going to run through the entire experience per se, but that is a project called basically Launchpad, and that project is basically a bunch of containers running parts. Well, you might say that Launchpad itself is a collection of microservices, right? And so what I did is I just clicked on the link to the front end for this experience. And as you can see, we've got the 3 runtimes. You'll eventually see Node.js pop up here. And what I can do is actually go on to the next screen. I apologize, that's small text. But basically on the left-hand side, it says, do you want to do this entire development experience online, or do you want to download a zip file locally and just try it out on your desktop without having kind of the end-to-end experience? So if we choose the end-to-end experience, I got to log in. So the nice thing is this actually ties into SSO, right? And what they want to do is, in this case, okay, it did single sign-on. We're using Red Hat SSO to connect your GitHub account with this app, along with, if you're running this online, OpenShift Online, so it's single sign-on across all the environments. So we have multiple examples. We have a database example. How do I externalize configuration? The health check I mentioned. Secure an endpoint with Red Hat SSO. In this case, it's just a simple database example. I choose the application runtime. Let's say I choose Wildfly Swarm. I got the team here in front of me, so I got to do that. I add a project name. We'll call it Swarm CRUD-session, because this is a database kind of CRUD app, create, remove, update, delete, or whatever. And then I could actually launch this on OpenShift. So it's actually going to go take this project, fork it to my GitHub account, which means over time, even after I run this example, I can go to my GitHub account, make changes to that application, extend it, do neat things with it, try things out. And then when I save that, if I make a commit, it actually kicks off the continuous delivery pipeline and actually deploys the app on a commit. So one really quick, let's see if I can do this here. I actually have it already running as well. So, oh, no, this is the one that's still running. Uh-oh, that's a problem. Let's do that one. Here we go. Here it is where the example is already running on my desktop. It deployed a database. This is the continuous delivery pipeline, all running on OpenShift. And this is the actual UI that kind of shows it. And I go look at the code. I can understand how we've actually made this run on OpenShift, any kind of work, any kind of configuration that you might need to do. Over time, we want to reduce as much of that configuration as possible. So we really want to make it easy, right? So, all right, I think we're out of time, and I'll take questions outside if you have any additional questions, right? Thank you.